So I'm going to prove Viviani's theorem, where I'm going to show that no matter where point P is, all three lines, x plus y plus z, will still be equal to the height. So basically, the area of ABC, the whole triangle, is equal to, well, base times height over 2, in this case base is s, which is equal to 1 times height over 2, which is just h over 2. Now what happens here is we can split this triangle into 3 smaller triangles. So we draw dotted lines to each of the vertices. And then you can see 3 distinct triangles, right? You see one blue triangle, you see one yellow triangle, and then there's a remaining triangle right here. So the area of the big triangle ABC would be the orange one plus the yellow one plus the blue one, right? And what we can do is find the area of each of these smaller triangles. Remember, the formula for the area of the triangle is base times height over 2. So for the orange triangle, the area would be, well, base is x, the height is, base is s, the height is x, over 2. But then since s is 1, that's just equal to x over 2. And as for the blue triangle, well, the base is 1, the height is z. 1 times z over 2 is just z over 2. Similarly, the yellow triangle is just y over 2. So now we have an equation. The x over 2 plus y over 2 plus the z over 2 equals to, well, as we said before, h over 2. Therefore, x plus y plus z equals to h. There's 2 points here. Let's call them P and Q. Now the shortest distance between these 2 points will always be a straight line, right? This is the shortest distance. Let's call this line, let's say L. What this means is any route from P to Q that's not a straight line cannot be a shortest distance. It has to be longer than the shortest distance, right? So if I have a squiggly thing going from P to Q that comes up here, since it's not a straight line, it has to be longer than the shortest distance. And using this, we can prove that the sum of the 2 sides of a triangle always has to be bigger than the third, right? Let's call this side C, and let's call this P and Q. Side C will always be the shortest distance. So, since there's a third vertex over here, what happens is we have another route from P to Q. But since this route is not a straight line, you know it has to be longer than the shortest route. So if we call this side A and this side B, then that means this distance, which is A plus B, has to be bigger than the shortest route, which is C. Right? We can see that if A plus B was somehow less than C, that would be impossible to form a triangle, because you can't have a distance shorter than the shortest distance. So A plus B is smaller than C, this is impossible. What if A plus B is equal to C? Well, since C is already the shortest route, and it's a line, we would have another shortest route, which is also a line. So in the end, you would have 2 lines, and that wouldn't be a triangle. So this is the only possible way to form a triangle. But remember, it's not only for one side, right? If you twist the triangle this way, now, okay, we have a new base. We have these 2 points. This is a straight line. Boom. This route has to be longer than here because it's not a straight line. Similarly over here. So that's why it works for every side, right? A plus B is bigger than C. A plus C is bigger than B. And B plus C is bigger than A. So I'm going to prove that each of the sides A, B, and C must be less than half. So we already know that C is less than A plus B, B is less than A plus C, etc. Now we know that all of these sides have to be bigger than 0, because if it's 0, then the side doesn't exist, and that wouldn't form a triangle. And if the side is 1, then the other sides have to be 0, and right, that can't form a triangle. Now let's replace C, B, and A with x, okay? Let's represent these values with x. Now let's replace A plus B, A plus C, and B plus C with the value x plus y. Note that y can be anything as long as it's positive, because we know that this is bigger than C, so it doesn't really matter what y is as long as it's positive. So then we can form an equation. We know that A plus B plus C equals to 1, right? So if A is x, then x plus y is equal to 1. And then we can simplify the equation. You can see what I did here. And then in the end, we find that x is equal to half minus y over 2. Now, remember that y is positive. So that means x is equal to half minus y over 2. And we can clearly see that that's smaller than half. Because if you're minusing a positive number, it'll always be smaller than the original amount. And then we have the proof. X is therefore smaller than half. And since x represents the values of A, B, and C, that means A, B, and C all have to be smaller than half in order to form a triangle. So we need to draw a line on this equilateral triangle to split the yes triangles from the no triangles. And guess what? That line is the half point. Here's why. So a plus b plus c is going to be equal to height, and the height is 1. So we know if a is larger than half, then no triangle will be formed. That means if this a stick was to penetrate through this line and went over here, then no triangle could be formed. That's why I wrote a no here. If a was less than half, that means, well, imagine this line was cut and the a line ended here. A triangle can be formed. But what if a is equal to half? Well, that's the borderline. That's the borderline between a yes triangle and a no triangle. And that's what this stick is for. This a stick is exactly equal to half of the height. That means if I slide the stick across this line, B and C can always be altered. And because of Vienna's theorem, we know that all three of these sticks still add up to 1. And that is why the region below this is yes, the region above is no triangle. Now, this also applies to another side, right? If we were to flip the triangle this way, this would be the new height, this would be half of the height. If a is larger than half, then no. If a is smaller than half, then yes, this is the borderline. And it's the same thing for the last side. So in the end, we have 4 equilateral triangles, 1, 2, 3, 4. 3 of them are no, 1 of them are yes, so the probability of landing into the yes triangle is simply 1/4. And that means the probability that splitting a stick into 3 pieces forms a triangle is equal to 1/4.